Hello, everyone, and thank you for joining me today. My name is Jason, and today we are going to talk about rotary engraving setups, applications, and some of the major differences between roller and chuck style rotary systems. We'll also cover setup tips, wrap engraving, pricing, and some of the common mistakes users run into when trying to improve their production workflow. Here we are looking at several examples of modern rotary attachment systems and configurations. Rotary attachments are designed to expand the capabilities of your laser machine by allowing you to engrave cylindrical and tapered objects such as tumblers, mugs, glasses, bottles, pens, and many other products. Different rotary systems serve different purposes. Some are designed for speed and simplicity, while others are designed for precision and maximum holding power. Understanding what each type of rotary does best is one of the biggest factors in improving both production speed and engraving quality. This slide shows the two main categories of rotary systems: roller rotaries and chuck rotaries. Roller rotaries support the object using friction between the rollers and the item being engraved. These are generally faster to load and unload and are extremely popular for production environments. Chuck rotaries physically clamp the item into place using jaws similar to a lathe chuck. This gives better centering and holding power, especially for irregular objects, tapered items, or smaller diameter products. Neither system is universally better than the other. The correct choice depends entirely on the application, the material, and the production goals. Rotary systems work by replacing the normal y-axis movement of the laser with rotational movement. Instead of moving the object back and forth linearly, the rotary attachment rotates the item while the laser engraves. The laser software calculates movement based on either steps per rotation or object diameter, depending on the rotary type being used. Proper calibration is extremely important because even small inaccuracies can cause distortion, overlap, gaps, or stretching in the final engraving. This is one of the reasons setup matters so much in rotary engraving. A correctly calibrated machine produces consistent and repeatable results. Modern roller rotaries offer several important advantages. First, they are extremely fast to load and unload, making them ideal for high-volume production environments. Second, they are capable of handling a very wide range of diameters without major adjustments. Roller systems also allow for easy positioning of cups and tumblers and generally have fewer moving parts compared to chuck systems. For many production shops, a roller rotary is the preferred solution because of its simplicity, speed, and ease of use. Chuck rotaries shine in situations where holding power and precision are critical. Because the object is physically clamped into place, chuck systems excel with tapered items, oddly shaped objects, mugs with handles, pens, and smaller diameter products. They also improve repeatability because the object is centered more consistently. Modern chuck rotaries have evolved significantly, offering better adjustability, faster setup, and improved support systems that make production more efficient than older designs. One of the most common questions people ask is whether a rotary attachment is worth the investment. The answer depends on what you want to produce and how much versatility you need. Adding a rotary dramatically expands the products you can offer customers. It allows engraving on tumblers, bottles, mugs, glassware, tools, and countless specialty items. For many laser businesses, rotary engraving quickly becomes one of the most profitable areas because customized cylindrical products are always in demand. This slide covers the setup process for a roller rotary. The most important thing when setting up a roller rotary is understanding that the roller diameter remains constant while the object diameter changes. Proper steps per rotation calibration is critical. You also want to make sure the object is level and securely contacting the rollers to prevent slipping. Taking the time to correctly calibrate the rotary saves a tremendous amount of frustration later and results in cleaner, more accurate engravings. Chuck rotary setup differs from a roller rotary in several key ways. With a chuck system, the steps per rotation generally remain constant while the object diameter changes within the software. The object must be centered correctly in the chuck to prevent wobble and distortion during engraving. Tailstock support may also be needed for longer items. A properly configured chuck rotary provides excellent precision and repeatability, especially for difficult or regular items. The low-power tape test is one of the simplest and most useful calibration methods available. By applying masking tape to the object and running a low-power outline test, you can verify positioning, alignment, scaling, and wrap accuracy before committing to the full engraving. This saves both time and material costs because mistakes can be identified before the actual engraving process begins. It is a simple technique, but one that experienced operators rely on regularly. Proper alignment is one of the biggest factors in obtaining professional results. This slide demonstrates quick alignment methods that help ensure the laser is positioned correctly before engraving begins. Using reference points, framing functions, and alignment tools allows for more consistent results and helps reduce wasted products. The goal is repeatability and efficiency. The more repeatable your setup is, the faster and more profitable your production becomes. This slide illustrates motion direction and rotational behavior during engraving. Understanding how the object rotates in relation to the laser movement is critical for avoiding mirrored engravings, incorrect orientation, and scaling issues. Every machine and software combination may behave slightly differently, so learning your system's motion characteristics is important. Once you understand these fundamentals, troubleshooting becomes much easier. When doing wraps, it is important to understand that wrap engraving is completely different from standard cup engraving and must be set up accordingly. The setup differs between roller rotaries and chuck rotaries. With the roller rotary, the roller diameter remains constant while the steps change. With a chuck rotary, the steps remain constant while the object diameter changes. In either case, you want to set up the software using a 1:1 or 2:2 inch scale in order to obtain proper calibration. The steps per rotation are simply the number of steps required to complete one full rotation. That number is not universal and can vary significantly between machines. Once the scaling is correct, you then create your template. The template is what determines how the wrap fits the cup. You do not change the rotary steps to force the design to fit. If the wrap comes up short or long, the template itself is what must be adjusted. A common mistake is stretching artwork by 5 to 10% because some users believe anything using scale functions will appear squashed. The reality is that you simply need to use the correct rotary function for the correct application. This slide discusses taper warp systems inside Lightburn. Tapered objects introduce additional complexity because the diameter changes from one end of the object to the other. To compensate for this, taper-specific templates and distortion adjustments are used. When configured properly, tapered wraps can produce extremely professional full wrap engravings, even on challenging objects like tapered tumblers. Here we see practical examples of taper warp layouts and how artwork is adjusted to compensate for varying diameters. The key takeaway is that successful taper engraving relies on preparation and template accuracy. Once a proper template has been created, repeat jobs become significantly easier and far more consistent. One of the biggest mistakes in the laser industry is undervaluing your work. Pricing should reflect not only material costs, but also machine time, setup time, experience, overhead, maintenance, failed products, software costs, and customer service. Rotary engraving often requires more setup and calibration than flat engraving, which means it should be priced accordingly. Understanding your value and charging appropriately is essential for building a sustainable and profitable business. That concludes the presentation. I appreciate everyone taking the time to join me today, and I hope this presentation provided useful insight into rotary engraving systems, setup methods, wrap engraving, and production workflow. If there are any questions, I would be happy to answer them now. Thank you again for your time.